This is going to be page 2 of lesson 4.3 on exponential functions. And so we're going to continue with example 2. So 16, this value out front, that is our a. And I'm just going to go and write up here our basic form for the exponential functions. And as a reminder, a is going to be your start value, and b is either going to be your growth or decline factor. Remember, if b is greater than 1, it is growth. And if b is in between 0 and 1, in other words, a fraction, it is going to be decay. So let's take a look how this graph is going to differ from the one on the previous page. Now, for this, we're just going to go and pull out our calculators to evaluate. I'm going to start at the bottom of the table because I think it makes a little more sense to start there. So we're going to have our 16. I'm going to put parentheses. I'm going to put my 1/2 in the parentheses, and I can do that as a 1/2. I could also do this as a fraction. This calculator does not do fractions the same way as ones we use in the classroom, but that represents a 1/2. But I think I'm just going to go 1 divided by 2. I could also use a 0.5. And then caret, and then we'll put 3 as our exponent. So we wind up with 2 as our answer. Now, where does the 2 come from? This one I will show kind of the work by hand. Y equals 16. And then 1/2 to the 3rd power. That means we have 3 1/2s. Right? So there's a 1/2, and a 1/2, and a 1/2. And when I multiply all these bottoms together, we get 8. And when I multiply all these ones, and we can multiply the 16 in with it too, right? When we multiply whole numbers with fractions, the whole number multiplies to the top. So we're just going to get 16 over 8, which is 2, and then there's our result. Then I can go ahead and come back up here, and we'll change that 3 to a 2. And now we get a 4. Come back up here and change that. Oops, I don't know what happened there. We're going to change that to a 1. Now we get 8. And change that to a 0. And we should get a 16, right? Because that's our start value, and we do. I'm going to go ahead and stop here. I think this might be enough to follow a pattern. 2, 4, 8, 16. Looks like these values are doubling as we're going up. 32, 64, 128. Now we could confirm that. I'm going to go back up here, and I'm going to put in our -3. Please note I'm using this negative, not a minus, right? Because we're not subtracting 3. It is a -3. And there's your 128. So that is confirmed with those values. I wonder if it's better with this off. Yeah, we're going to turn off that light. Okay, it does create a little bit of a shadow here, but I'll turn it off when I'm using the calculator. All right, so these are our values that we need to graph. Now, one thing that's kind of challenging with these type of graphs is when you pick a scale, some values will work really well with the scale, and other values will be really hard to graph, so you just have to do your best guess. But we will put our 1, 2, and 3 on this side. I'm going to turn that back up. Ooh, boy, bright. Okay, that's better. -1, -2, -3. And then, like, how far up do I want to go? Do I want to try and get all the way up to 128? Or would 32 be enough to show that graph? And so I'm kind of leaning towards making sure 32 gets on there, but I may not be able to fit all the points. If I make this all the way up to 128, how do I graph 8 and 4 and 2, and then the values even get smaller here? So there is kind of a limit, so you just got to choose what gives you the general shape of the graph, and I think going up to 32 will do that. Now, what do I want to go up by? I think if I go by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So 32 would be like the next value up. So I think we could at least approximate it. All right, so let's go ahead and put in these values. So 3, 2 would be right here, starting at the bottom. 2, 4 would be right here. And 1, 8 is right there. And then 0, 16, -1, 32 somewhere up here. So there's your general shape. Now what happens here? As we continue to go this way, the value should continue to cut in half. So at 4, I should get a 1. Right, that's 2, so 1's here. And at 5, it should drop to 1/2, and then 1/4, then 1/8. So this graph will kind of approach 0 here as we go down. I'm going to go and continue this one up. And that's the general shape of the graph. So that's your exponential decay. All right, so we've seen a graph of both growth and decay. And once again, if you get a value bigger than 1 here in as your base, that is going to be growth. And if it's between 0 and -1, it's going to be decay. All right, let's go ahead and take a look at example 3. Here we're going to look at a situation where we have 200 bacteria. That's what we're going to start with. And then this colony doubles every 6 hours. So for this, I think a table might be our best approach. So they're using f of t, so t instead of x, and then f of t instead of y. And all that means t is time, and that's going to be in hours. So I'm going to put hours above t, and here we will put number of bacteria. Now it says our start value is 0, so we'll start times 0. Sorry, our start value is 200, so at time 0, we have 200 bacteria. And it says it's going to double every 6 hours. So I don't know that it makes sense to put values like 1, 2, 3, and 4. I think 6 would be the next value you'd put on the table. That would make the most sense. And at 6 hours, this should have doubled, so it'll now be 400. And then if we go another 6 hours, it should double again, and now we should be at 800. And then another 6 hours, that puts us at 18 hours, and we should be at 1600. And so that's your pattern that's happening, right? So we could continue to fill this out. Now, it has a couple questions for us. How many bacteria will there be after 24 hours? So we can continue this table, and actually the next one is 24 when we add another 6. So that would be 3,200 bacteria. Now, how many hours will it take to reach 25,600? Well, we would just continue to extend down this table and continue to add values. So we'd have like 30, 36, 42, 48, right? We just continue to add values and continue to double until we reach that amount. So I'm just go ahead and just finish that. Go ahead and double out to the end of the table. So pause, double them out, and then unpause, and we'll compare answers. Okay, so hopefully you have this table filled out. The next one is 6,400, and then the next one is 12,800, and the next one is going to be 25,600. Oh, and that's what we're looking for, right? So actually 42 hours. Now, how do I write an equation for this? I'm going to go and start with my basic form, y equals ab to the x. We know the start value is 200, so we can replace the a with 200. But the b, what should that be? Well, we know that it is doubling. So if it's doubling, we're multiplying by 2. So that means your base is going to be 2. But here's the problem. If I just put an x here, that is not going to create the doubling we want, right? Because then it's going to double every single hour. If I put 1 in here, it'll give me 400. But it's not supposed to reach 400 till you get to hour 6. So I'm going to have to do something different with the exponent so that it only doubles every 6 hours. And one way I can do that is by putting a fraction here, and I could make my exponent x over 6. So when I put a 1 in, my exponent's only 1/6. If I put a 2 in, it's 2/6, 3, 4, right? When I put a 6 in, now it's 6/6, which is 1, and that would actually create 1 multiplication of 2. So once I plug in 6, I get 2 to the first, which is 2 times 200 gives me 400. So this would actually be the equation in this case. So sometimes if the doubling or whatever's happening with the exponential model, whatever the growth rate is or decay rate, if it's not happening every hour, we might have to adjust this. All right. So I think we've answered the questions for this. At 24 hours, we're going to have 3,200 bacteria. And then for number 3, there will be 25,600 bacteria at 42 hours. So just a reminder, we have 3 options when we're dealing with functions, right? We can make a table, we can try to create an equation, we could do a graph. In this one, the table makes the most sense. We were able to get all of these values in the table by simply doubling the values as we increased by 6 hours. I think this is definitely the easiest way. I think the equation's a little bit tougher because we had to figure this piece out, and I wouldn't even try graphing it. I mean, I don't think there's any advantage to doing that. So that's why we have 3 different methods. Sometimes one method is better than the other. Now, if I wanted to find how many bacteria after 500 hours, I probably wouldn't want to do this. I'd probably want to figure out what the equation is and plug in 500. So there is a way to go about that, and so it just really depends on what you're trying to do. All right, so that is going to end the lesson for page 2. Please continue on to page 3.